Hello, everyone, and welcome to the webinar Introduction to Java Programming for Absolute Beginners. My name is Helena Barmer. I will be the moderator of this event. I am also the founder and leader of People in Data. People in Data is hosting this event today. People in Data is an online nonprofit community, and we offer free online events, and we hope to gather people worldwide through tech. Saying that, I will be so happy if you can just write in the Zoom chat where you are streaming in from today. Me and the speaker today, we are streaming from Sweden. So we have another one from Sweden. Hi, Rebecca. Nice to see you here. And so before we begin, I just want to tell you a little bit about the structure of this webinar. You are all muted by default because this is a webinar setting in Zoom, and only the panelists will be able to speak. So that's me and Mantas Sliazas. I will soon introduce him to you. If you have any questions, any general questions, you can write them in the Zoom chat. You also have a Q&A box. So when Mantas is presenting, and if you have any questions regarding the presentation, just write your questions in the Q&A box. For any other concerns or any other questions, or if you want to connect with us or with each other, just write in the chat, in the Zoom chat. So now it is my honor and pleasure to introduce our workshop leader for today. His name is Mantas Sliazas. He is a student in object-oriented programming and AI in Sweden. He used to be a kitchen chef, and he's now turning, or maybe I should say cooking himself, into a programmer instead. Hi, Mantas. How are you?
Hi all, I hope everyone is well in these desperate times, and thank you, my dear Helena. I'm fine today. I hope you're all fine today. Well, as you may already have mentioned, my name is Mantas, and I'm very pleased to meet you all. I am a former kitchen chef, and as you said before, I am cooking variables and data types, on which we're going to take a closer look today. This is going to be a pretty simple and easy webinar just for the complete beginners, as Helena mentioned before. We don't want you really to get too much information so your head could explode, because programming, well, there's a lot of different things you can do here. There is extremely lot of information, well, today we started simple, and then we will see how it goes. So I may talk a little bit more about myself. I started studying not for so long ago, and I can say that to take this huge step once you are an adult, it's kind of hard, but I'm very happy that I did, because programming actually improved my logical thinking, and well, I just love solving problems. So maybe that's the reason why I fell for it, and we will see how it goes for you. Maybe you are future programmers yourselves. So I believe without further ado, we can just jump in and see what we have for today, right? Oh, and by the way, if you have any questions, don't hesitate. Just text them in a chat or Q&A, so we will be happy to answer them. All right, let's see. So what is programming? Well, I believe many of you have this question for today. Basically, programming is a process of writing computer programs. So in today's world, all the applications, all the web page, video games, TVs, industries, they are all based on some kind of programming. And without programming, we probably wouldn't have all of these great things, and our society wouldn't be probably so advanced as it is. As you can see, we have also written, I hope you all can see with the mouse cursor, so I'm going to show some specific places. There are around 700 different programming languages, and as you can see, there's only a handful of them that are being used. By that said, I could probably count up to 20 different programming languages which are being used by bigger groups of developers or programmers, basically the same. And these huge tech companies, they are all probably working on just around 20 or 30 different programming languages. So I believe you have the same question as I do. Why is there so many different programming languages? and I think it's easiest to describe it in a simple example. Let's say we have a group of programmers that are working on the same programming language for multiple years on multiple projects, and then one day they realize, wow, this stuff we are writing, it takes a long time to do, it's kind of complicated, and there is a lot of unnecessary code. What can we do about it? And that's basically a birth of a new programming language. They take the concept of the old programming language, put it into the new one, and then they are basically remaking some features, some stuff in that language, which makes it easier to be well, to achieve the results you want to achieve. So as you can see, there are 700 different programming languages. All of them has their own upsides and downsides. It all depends on what are you using the program for. We're going to talk about this a little bit more. You have any questions so far? Just shoot it out. I will try to answer them as good as I can. All right, there are of course also 4 different types of programming: procedural, functional, object-oriented, and scripting. We are not going to dive deep into what procedural and functional scripting programming types are, because Java, which is our main course today, is actually object-oriented. So we're going to keep it simple and we're going to keep it in that way. I just want you guys to know that there are more different types of programming styles, but object-oriented is one very popular today. And talking about object-oriented programming, well, what is an object-oriented programming? Well, basically, it's a programming type where everything you do is based on objects. And then you may get another question: what is an object? Well, in programming, an object is, you can put it into a small example. For instance, let's say we have a web page, and that page has a lot of users, right? Each of these users, they have a sort of properties. Let's say it could be like username, password, an email, address, and so on. All these properties combined together, they make an object. And these objects, they can interact with each other, and they are, well, basically you work with the objects when you do Java. When I say they interact with each other, let's make a quick example of something else. Let's say we have an object of vehicle or a car, right? The vehicle has wheels, has engine, has doors, and has, well, speed or something else. But speed we could actually put into another object, which could be an engine. An engine has its own properties. So when I say they interact with each other, I basically say that an object can include other objects and so on. We're not going to rely much on objects just today because it's quite a heavy subject and we want to start as simple as possible. So we're going to probably leave it for some other time. And then we can see there are, I don't know if you have ever heard about different programming languages, but object-oriented programming languages are Java, one of the major ones. Then there is, of course, JavaScript, but JavaScript can be like, it's kind of flexible language, so you can do pretty much different programming styles with it. It could also be scripting language, but you can also write object-oriented programming in JavaScript. Then you have Python, which is mostly for artificial intelligence, C++, and C# and so on. I could also probably add that, well, before all of these languages existed, there was one big language called C. I don't know if you have ever heard about it, but C is like a great grandfather for Java, C++, and C# and many other languages. And that's what I mentioned before, how 700 different programming languages developed. Well, C was the major language, and it was kind of difficult to do some things with it. Some functions were requiring a lot of code, which made applications and web pages loaded with a lot of unnecessary and duplicated code, and the applications were harder to run. Then a group of developers decided, well, we can probably just remove some of this stuff and make it easier, maybe build in some different functions in this language so we can have a easier use with it. So that's how all these languages evolved. I could probably also mention in the next slide that why Java? Well, Java is one of the most used programming languages today. It appeared back in 1995 and is still very appreciated. From my personal experience, I could add that, well, every programming language has their own upsides and downsides. And well, many programmers believe that negative side of Java is that you have to write a lot of unnecessary code, or not probably unnecessary code, but if you want to do something small, you have to write a lot of code for it. But on the other hand, Java is very strict, and that's what I like. I mean, many other different programming languages, you can search a lot of information about them on Google, find stuff how to write one thing or another, but usually they can be so different that you don't really understand what is what. In Java, basically, if you're Googling Java, you can see that, all right, this guy has done something, but the only thing that is different is the logic, the way he did it. So the syntax, and what is syntax? Well, syntax is basically like a grammar for programming language. So like we are talking Swedish, me and Helena, and we write Swedish. Swedish has grammar. It's basically the same for programming languages, and they have something called syntax. So the syntax or grammar is the same once you Google it everywhere. So it makes it easy to Google. It makes, since Java is developed since 1995, it means it's pretty much advanced and you can do a lot of things with it. That's another plus. The third plus, I would probably say that there are a lot of different jobs for Java developers. And well, that's my strong pluses for Java. And probably that I started with Java and now I like it because I finally know how to write code and how to get it to work. Do we have any questions, Helena?
No questions so far. So if you have any questions, just ask them in the Q&A box. And if you have any questions for me, just ask them in the Zoom chat. You can go ahead, Mantas.
Yes, thank you. I keep on. As I mentioned before, Java is very similar to C#. They are like brother and sister to each other, I believe. And these languages, they consist of data types, methods, objects, and classes. We already covered a little bit of objects. I don't know how much you remember, but objects, well, it could be a small object that has its own properties. Classes, however, we're not going to cover so much about classes, methods, and objects today because they are quite heavy and kind of hard to understand, especially in the beginning. But I can put a couple of words about what classes are. Since now we know a little bit about objects, classes is something, some kind of a template of which you can sample these objects. So let's say we have a class of person. This class can sample different persons, which are objects. So let's say that we have an object made from the class, and it has like name Mantas, which is my name, and it has my password and my email address and my well, whatsoever address and so on. And then we, out of the same class, we can do the same object, for instance, Helena. And in that object, Helena has her own name, has her own email address, has her own password, and so on. So basically, out of the classes, you sample pretty much the same. You sample objects with the same properties, just different attributes. If it's clear, if you understand what I mean. On the other hand, methods. Well, methods are something of. We can put it like this: a method is a piece of code that can be used in multiple places in our code. And it does some kind of a function. So let's say we have a method to calculate two numbers, which accepts two different numbers inside the method. And that method then calculates these two numbers, like for instance, adds them together and outputs, well, returns the sum of them. So this is what methods, objects, and classes are. Data types, I'm going to leave it for a little bit later. We're going to dive into them right about now. We have two different major data types in Java. As you can see, one of them are primitive data types, which are byte, short. Int is short for integer, like a number. Long, float, double, boolean, and char. To sum all of these, well, byte, short, integer, long, float, and double, all the way up here, all these data types are actually numbers. So they can be either negative numbers, zeros, or positive numbers. Booleans, on the other hand, well, we're going to talk about them a little bit later also. They can only be true or false. They have only value of true or false, and then the character, or char, in Java. Char is basically one single sign, letter, or a number, you name it, like something like that. And then we have a little bit bigger subject, which is non-primitive data types. Strings we're going to talk about today, which is basically text. And then we have also arrays. We are not going to talk much about arrays and classes. Classes I have already mentioned a little bit, but arrays, well, to understand the meaning of array is just like a list. And let's say if it's a list, it could be a list of like strings or integers or objects whatsoever. Like I mentioned, we're gonna talk about strings a little bit. We have some data types we would like to show you today. But before that, we're gonna dive into what are the different data types or what their differences are. So I know this could be pretty hard to understand at the beginning. I will try to do my best and explain them for you. Primitive data types are predefined. What predefined actually means that all these data types, primitive data types, they already have a value in Java. So they cannot be empty. Like you can see here, a primitive type always has a value. Non-primitive type can be null. So like string, array, or class, they can be empty, they can be null. And these classes are created by the, or not classes, these types are created by the programmer. So arrays, strings, and classes are created by the programmer, and then they can also be empty or null, while primitive data types cannot. So all these numbers and Boolean, which is true or false, they cannot be empty, and they are already predefined by Java. A primitive data type starts with a lowercase letter, while non-primitive type starts with an uppercase letter. As you can see up here, if I move back a little bit, primitive data types, they all start with the lowercase letters, while non-primitive data types start with huge uppercase letters, right? So
we have a question, Mantas. Sorry for interrupting.
Yes, of course.
This is about the methods of function, and I know we're not getting into this today, but it's a question from Maish. I'm sorry, I hope I pronounce it right. Are methods and function the same, is the question.
Our method and function, it's basically the same. It's just two different words. It's basically like developer and the programmer. It means practically the same thing, but many people can get confused because of that. So functions, I would say that you usually call a method a function in JavaScript. I don't know why is it like that, but in Java, people usually call methods or something like that. But actually, there is no bigger differences, I believe. You can call it a function, you can call it a method. It basically does the same thing. It has a small block of code which does something and executes something and then returns something, right? So I hope I answered your question. It's practically the same thing. Yes.
Yeah, we have another question, but I think we will get to that now. So it's examples on primitive and non-primitive data types, but we will get to that, Akshay.
Yes,
right, Mantas?
we're gonna talk about them a little bit more. I'm even going to show you some couple of examples how to type them and how to declare them, how to define them. All these words can be kind of different to understand at the beginning, but declare or define a variable or a data type, it's basically the same as writing it down in a code editor. So data types we will use today, and I could personally say that these data types are the data types I use the most. I'm gonna soon explain why. Integer, which is or int is a short for integer, which means a number, double, and so on. We're gonna work with these today. I'm gonna introduce them soon enough. And as you can see here, our data types, for instance, an integer stores whole numbers from -2 billion to +2 billion, which is very heavy, big number. So when I said that I mostly use integers, if I want to have a whole number, I choose integer. Why? Because as you can see, it's not so very often you use something above minus or +2 billion. Well, probably if you're working on a project where there is a lot of mathematics, then you probably want to choose another data type. But even there, I believe that you can come a long way with integers or ints. Doubles, they are fractional numbers, decimal numbers, sufficient for storing 15 decimal digits. With that said, I could probably show an example. If you have a number like 3 point, then you can have 15 different digits after that, which makes it also pretty long and heavy number. And that's why this data type is so much used by me personally. I don't know, many other programmers probably choose some other data types, but I don't really believe it's necessary. Booleans can only be true or false. Now, this one is a bit hard to understand, especially in the beginning. What do you mean by true or false? And it's very hard to describe it. I think it's going to be a lot easier if I show it to you later, once we are coding. Booleans are very much used into something that's called conditionals. We're not going to cover them much today. As I mentioned before, we wouldn't like your heads explode from a lot of informations. Well, we're going to cover it a little bit, and I'm going to show you how they work. I'm going to explain you while I'm coding. So, and then we have strings. And as I mentioned a little bit before, a string is a sequence of characters, which makes it basically a text. And one thing to remember, since string is non-primitive data type, as you can see here, right? String is written with a uppercase S, and while these others are written in a lowercase. So that means string is a non-primitive data type, and it doesn't have to be it doesn't have to have any value. It can be empty or null, because I believe you remember that programmers create these data types themselves, while Boolean, double, and int are already predefined or created in Java. So when I say already predefined, an integer, it cannot be null, it cannot be empty. It can either be null, 0 or minus something or plus something, some number. The same goes for double. They can also be negative, positive, or 0. And Booleans, they only return true or false. So the strings are also always written in a double quotation marks or quotes. As you can see, we have a small example of a string, and it says my name is Mantas. So that means this string also includes the white spaces, as you can see. We're gonna try and practice to write them a little bit later. Let's see what we have else for today. All right, and one of the major or key things in programming is variables. To put it literally, variables are containers for storing data values. Sometimes I'm forgetting to ask if there are any questions. Helena, do we have anything?
Yeah, we have just one now from Akshay. What is data type conversion?
How do you convert one to another, you mean?
Akshay, maybe you can just write a little bit more in depth what you mean with the question, please.
Because there are ways you can convert one data type to another in Java. It requires to access some different methods. Let's say we have a variable with the data type, and then you can convert it to another one. To do that, we only need one simple method, which is called parse. I'm not sure if I'm answering the question correctly.
So you're saying data type of conversion is nothing but typecasting?
Well, this is a little bit more advanced thing to say. Well, typecasting usually goes for classes. If you're gonna go deeper into advanced Java or programming. But there are possible ways to convert one data type variable to another one, and this is probably made with, let's say we have a data type of double, and we have a variable for that, like double some number equals something. We can parse it, we can convert it to an integer by typing integer.parse. We're gonna call a method parse, and then we're gonna input integer variable in there. I'm not really sure if I answer your question correctly. I believe I wouldn't like to mix this advanced stuff in here because a lot of people may not follow. So I can say that if you have a further question, feel free to type it down, and I will try to answer it after, maybe after the webinar, so I can contact you or something if it works. Do we have any more questions, Helena?
No, you can go ahead, and Mantas will also show you some live examples in an online compiler, so just wait for that. Of course. Yeah.
And with online compiler, we're gonna go straight to it after knowing what the variable actually is. Well, like I mentioned before, being back on topic, variables are sort of containers. I usually prefer to them as a box with a name. So let's just imagine one thing. Let's say we have a box in our home somewhere, which has two things written on it. One thing is, for instance, well, accessories, and another thing written, gold, right? So in our case, we define a variable in this way: int, which is a data type, mynum, which is a variable name, and this variable stores number 3. With that said, imagine that our box with well, with a little text gold and accessories, where accessories actually are a type. So it says that accessories is something this box holds, right? And it has name on it where it says gold. And the content of that little box, it's what is inside the variable. So in this case, an integer or int is a data type, or a label, which is like put on the box. So we know that this little variable is an integer. mynum is a variable name. I could also mention that variable names are very important to write them as readable as possible. This is a common problem for many developers or programmers worldwide. For readability, it's good to have it. I personally like to write even longer variable names than to keep them short but not understandable. This in case somebody else reads my code and well, tries to maintain it. It's very hard to maintain somebody else's code when you don't know what this variable actually holds. We're going to talk a little bit more about that. We also have this equals sign, which is not basically the same as in mathematics, but in this case, an equal sign assigns some kind of a value to a variable, to our little box. And it's also called assignment operator. We're going to talk about different operator types today also. 3 in our little variable is clearly a number, and it is stored into this variable. So from now on, once we store this 3 number into a variable, we can only type mynum somewhere else in our code to access its contents or what it holds. And of course, one of the major problems I have in my code is that each Java statement must end with a semicolon. So basically, when we type a statement, when we type a line of code, we want to finish it with a semicolon, so the Java knows that, all right, this piece of code, this small line of code is already done, and we can move on to the next one. And that's where I would like to. I'm not really sure if many of you what kind of devices you are using to watch the webinar. But for those who wish to try to code along with me, you can open the link. I'm guessing Helena has already sent that link to you on the chat or something. Am I right?
Yeah, the link is in
Yes.
the chat, and you can just see if you are on a different device, or if you have the opportunity, just open that link and it will show, like Mantas is showing you now. You can just see this and use it straight from your laptop or computer.
Yes. Thank you, Helena. And now I could probably mention that, well, for starters, this is where we are going to write our code. There is already some code already predefined here because of the link. So we would like to get rid of this code over here, and we can just delete it. What these things mean here, well, don't worry about it. You don't have to know them right now because it's a heavy load of information to know them from the beginning. Just know one thing, that if you write your code in between these lines, it's going to work. All right. So I'm going to make some more spaces here. Another thing I would like to do, for those that are coding along with me, you can click on this small bill here to close that one, and then we can click on this square over here, so we can move the console over here. And what is console? Well, for those that never had programmed before, this is where we write our code, of course, and here in the console is where our code gets executed and something is going to be outputted. We're going to talk a little bit more about that and how to output code to the console. But for now, I wanted to show you how to define a couple of variables. So like we had in our example, we first write the data type. We can say that int, and when I also talked about very important variable names, but in this case, we can just use my num, which is equal to 3. And of course, the semicolon to finish the line, because Java runs the code in this way. First, it runs this line of code, and then it runs that line of code, and then so on, so on, so on. So all the code is executed from upside down by each line. So now we define one variable, and if we wouldn't have the semicolon, we would like to define another one, then we would get an error that there's a line of code that is not defined or is not closed. So that could, well, if we just keep writing our semicolon here, we would skip a lot of unnecessary bugs in our code and a lot of unnecessary errors. Helena, do you have any questions?
Yeah, but this is about if we can explain separately public static void main string arguments. So that's under the my class. If you just want to briefly say something about that.
Public class, my class, as we talked before, it's a class which is created by, well, basically this public static void main. It's something you have to have if you want to output your code. I'm not going to go deeper into what all of these means because it's going to take another half an hour to go through all of these things. But this is a class, and this, well, we could call it like a method, which is, well, open, public for the code to be executed. If you have any more questions about it, I can say it right now, because you people that wants to add me on LinkedIn and reach out to me if you have any questions, feel free to do that. Like text me, add me on LinkedIn, and shoot out some questions, some things that were probably unclear for you, and even if it has to do something with more advanced Java or programming, I will try to do my best and answer them for you. But what you need to know for now, that this public class my class is just a class, and this public static void main string args, well, it's like a method, and in this method we're going to write our code. Otherwise, everything we do, it would throw an error for us, so we couldn't expect to see any output here. So to going back on the topic, we defined our first variable, which is my num, and it's equal to 3. We could do the same with another variable, like int my num2, for instance, and we could assign a value of 2 to it. So when I was talking about that, each variable is read from upside down. So this variable runs first, and then this variable runs first, but they are not being outputted anywhere on the console. And we're gonna take a look here back again in the slides. We can cover some more general variable rules also. As you already may have seen, names can contain letters, digits, underscores, and dollar signs, but must always begin with a letter. So what it's meant here, that all these names, they can include numbers, underscores, dollar signs, but they must begin with a letter. And well, for the best practice, or the standard way, is to start the first letter with lowercase, and then every next word you're going to type, you type them with uppercase. We're going to see a slide about that pretty soon too. Yes. Oh, of course. Names, variable names, shouldn't or cannot contain any white space. So that means that no spaces here are allowed, because now Java wouldn't know if the variable name is my or num, and it's going to throw an error because it says that, well, variable is not closed with a semicolon or something like that. So no white spaces here in variable names. They are all connected, and they are all separated by lowercase and uppercase letters. Names are case sensitive. Oh, this is a fun one that creates many bugs and many errors for many programmers. My var with capital or uppercase V is absolutely not the same as my var with lowercase. These are two different variables. So let's say we define the variable my num here. We could add another or a third variable, which could be int my num, like this, and we put it to 4. These are two different variables. Though for readability, it's a good practice to avoid having the same names for variables, even if they are separated by capital or uppercase and lowercase letters, because it's very hard to understand once you're reading. Well, right now it's not so hard because we have 3 different variables, but let's say we have a code which consists of thousands and thousands of lines of code. If you find one variable with my num, which is a capital N, and you find another one with my num with lowercase one, it's kind of confusing to understand what they all do. So I usually avoid this kind of typing. As I mentioned before, variable names can be long as long as they describe the variable or what is stored in it. Yes, then we have some couple of reserved words in Java, and they are keywords to Java, which could be like int or boolean. These cannot be used as names. So for instance, if you have a variable here, if I can put it like this, int boolean equals 3. As you can see, this is not possible because keywords are marked in well, a little bit of this I don't know, well, they are marked with a different color, like purple in this case. It means that boolean is a data type, and we're trying to assign a data type onto a data type, which is definitely not going to work. So if you would like to write a name out of it, we can use boolean, but we can use it like this, my boolean, and then it's going to work. So no reserved keywords are allowed to be as names. One more thing I can add to all this. How do we write comments? It's very important because Nowadays, when people are programming, developers are more working on a code. Usually, if the code or a piece of code is hard to understand what it actually does, people usually put comments around it or over it, and the code stays above. So to do some comment, a single line comment is written with 2 slashes, and we can say that, well, we can comment something here, like keywords are not allowed as names. Then there are another line or another type of comments, because these comments only work for one line. So if I break the line, I cannot keep on commenting something. So we can add it. And this is a one-line comment. If you go down, we can do a multiple line comment also. And it is done with slash, asterisk, and asterisk slash, like this. So we can now write this is a multiple line comment like this. There's not so much else to say about comments, except that well, nowadays developers are commenting a lot of their code, and the comments are very used to comment. Let's say we have an application and we have some, well, bug or some error somewhere in the code, and we could probably assume that, let's say that, well, I think this line could be causing the error. How do I know that? You can just basically comment it out like this. So once it's commented out, it's not going to be compiled. And what compiled actually means, oh, I actually forgot to tell you guys about this. All the code we write is based on English, but this is not the code that our computers actually understand. What computers actually understand, they understand the code something similar to, if you can see here, the only language computers understand is ones and zeros, which looks pretty much like something like this. And this kind of code is basically not possible to read by any person. So what we are writing, the way we did here with variables and stuff like that, under the hood in our application we are writing our code in, it's going to be translated to ones and zeros. So all these variables, somewhere, we cannot see it, but somewhere deep down under the hood of the application is going to be translated to this code, and then the computer can display something out of it. So I'm going to put that to a comment too. I'm going to share all this code later for you guys. I'm going to tell you how I'm going to do it and where you can find it. But for now, I'm just leaving it like this, and I'm going to put some more comments before I release it to you, so you can access this code and see. Well, if you're trying something yourself and you forget how to do some certain things, you can also look at this code. So this is the code computer understands. This is the code we programmers do understand. And what we write somewhere deep down inside, it's going to be translated to this code and back and forth. You know, like if you want to print a result, this variable is going to be converted, and then it's going to be converted back to this variable, and it's going to be, well, it's two-way around thing, but it's the way it works. So right, no reserved keywords, we talked about that. Let's see here. Yes, as we talked before, camel case. This is a type of typing, and how does it look? Well, it basically looks like a camel case. First letter is lowercase letter, and the next word in a variable name is uppercase letter. It's pretty much exactly the same as you can see here. My, num, 2, well, there are probably two numbers here, so my and num, and my word is written in lowercase letter and the num is written in uppercase letter. we could have another variable, for instance, int my age is something, right? Let's say my age is 28, which is actually my age. Each word is written in camel case. So first word, lowercase, and all the other words to follow are written in uppercase letter. We can probably remove that. All right. Now is one interesting thing here. Soon we're gonna start working and displaying things to the console. This is the way how you print a variable or something else to console. I'm gonna talk about it more once I'm typing it. So let's say we already have a couple of variables declared, right? So I'm gonna type here system print line. Oh, and one thing also, when I started coding on my very first days of coding, I somehow mischecked this word. It actually says print line with a lowercase l. What I thought it was huge or uppercase I. So I always thought it was saying print in, and I was trying to get something displayed on my console, but I never succeeded because there was this error, and I of course couldn't understand the error either. So this is ln, print line, not in. And what it actually is, well, as we already talked about classes a little bit, system is clearly a class. Out is the variable, and print line is a method. We're not going to dive deeper into what it actually means, but and you don't really have to know that, because this basically prints out something to our console. But I can tell you that system is a class, and out is a variable, and print line is a method. Methods are also written with parentheses. So if you would like to print out, let's say, my number 3 variable, we don't have to write or type 3 here. Of course, we could do that too, but it wouldn't be the variable. It just would be the random number. If you want to print out the variable itself, we can write like my num, and then hit execute here. Oh, I forgot the semicolon like this. It's going to execute the code, and it's going to output 3, which is exactly what our variable holds, right? If, however, we could also write out 3 like this, but this number 3 is not saved anywhere, which means after we print it out, it is lost. So if the code is running upside from up, or how they say it, well, it's running in this way that the first line is executed, second line, and third line. And if we print out this number 3 here, it's going to be lost in the later, lower down here. If you're going to write another line of code here, the 3 is going to be lost. So it's going to be displayed once, and it's going to be lost forever, which variables are not. If we declare a variable, it's not going to be lost anywhere as long as we don't delete it from or remove it from over here. What we could also do, we could probably do it like this here. We can type my num plus my num2. And I think you already know what we're gonna get here. We're gonna get the sum of these 2 variables. Let's see if we are correct. Exactly. We get the sum of these 2 variables. So that means we can actually print things inside this method, system out print line, in different kind of way. It doesn't have to be only a variable. It could be like 2 different variables added, or if you would like to, I'm going to keep that for later. We could also, like we mentioned before, we could also write out a regular number or something else. But that doesn't, however, work with just a bunch of letters. Let's say we're going to type a word letter. This is not going to work. We're going to get an error, and I'm going to soon explain why. This works only with numbers. So now, since we know how to write something out to console, I would like to ask also if you have any questions, Helena.
No questions. You can go ahead, Mantas.
Yes, thank you. All right, we have already talked about integers, and well, what is an integer? Again, integer stores whole numbers, which are from -2 billion to +2 billion. This is a big number, and we already defined a couple of these variables. In the example here, we have integer number 1 equals to 10, and integer number 2 equals to 100. We could also, which we haven't done yet, we could also do like create a new variable with the result or my calculation and add these two numbers together. We can try that out here. Now, since we have two variables, we can do like this. We can create another variable. Oh, probably I'm gonna, just for readability, move them down. So it's gonna be easier for us to understand what we are dealing with. Like this. Let's say we would like to add these two variables in another variable, which is also very possible. We can type, or we can declare a new variable, which has to also be data type integer, because we are adding two integers together. So the result integer, or the result variable, must also be an integer. Int result equals my num plus my num2, and we close the statement. So from now on, this variable is the value of these two variables added together. We can print it out to see if it works. So exactly, it's 5. But if we might change one of these variables to, let's say, like 8, it's going to output number 10. So it works, and we can add them here, or we can add them directly here and print them out, like we did before, like my num plus my num2. The only difference here would be that this result is not going to be saved anywhere in the code, while this variable, is going to be saved. So we can access it later in our project, in our code. Right. We have covered some integers, and we have doubles, like we talked before. Double stores a fractional number sufficient for storing 15 decimal digit. However, it must be separated with a dot instead of a comma. It's an English way to do it. So a small example, the double is declared this way. Number 1 equals 1.5. And the same goes for number 2, which is equals to 2.5. So that's how we declare a double. We can try a couple of these two. We can do it like that. Let's say we're going to declare a double now. Double decimal number equals 3.5. And another double pay, maybe double. Number 2 equals 2.5. It's basically the same as the whole numbers, as integers. Just one major difference here is that if we would like to add an integer with a double, the double would be cut just to the whole number. So even if we would have like 3.8 and we add an integer and double together, this double variable would still be 8. So it's not rounded up or anything. It's just going to stay. The Java only checks the first number, and then it cuts off everything that comes after the point. This data type is very much used when we want to well, have a precise calculations of something, and it's very popular. It actually depends on we are working on and what kind of projects we are doing. I'm doing doubles sometimes myself when I'm typing the code. Mostly I'm using integers, but when it comes to the fractional numbers, I mostly choose doubles. Like this. Okay, we covered a bit of double, and now it's time to go to something a little bit more fun, in my opinion. We're gonna talk about strings, and strings, as we mentioned before, are a sequence of characters which combined together makes a text. String values, however, must be surrounded by double quotes. So when I was showing you before that we couldn't basically write like a plain word here, like word, it's not going to work. This word should be added to quotation marks like this, and now it can be displayed. Now I haven't declared any variable with or string variable. I just printed out the regular word. So we can print whatever text we want in a system out print line. But if we would create a variable, it will go basically the same way like double and integer. That variable is going to be saved in our code, and we can print it out whenever we like. So how do we declare a string variable? Well, since it's non-primitive data type, and all non-primitive data types are written with capital letter or uppercase letter, so that the same goes for strings too. So let's say string my name equals and quotation marks Mantas, and then we close the statement. This is the string variable we created. We could also print it out like we did with integers and doubles. My name, and it's going to get printed out Mantas. Another fun thing to do with strings is to add them together. Let's say like we can do like this, that we already have a string my name. So let's say we would like to, we can plus string and integer if we would like. Probably I removed my age variable. We create another one, int my age equals 28. Because this is not data type sensitive. System out print line is not data type sensitive. It can print out different variables, different data types at the same time. So if I would like to print my name and my age, it's going to work very well. Except we're going to get one error or one little problem here. Mantas 28, there is no white space. And that actually doesn't explain what Mantas is and what is the number. So let's say we have a couple of variables we want to use and we want to print them out in a console. We could do something like this. We can create a local variable in a system out print line with two double quotes, and we can say like, hi, my name is, and then we can add a variable here, which is my name, and then we can follow up with more text. For instance, and my age is, and my age is, and we can plus another variable inside here, my age. I know this can be kind of confusing at the beginning because I remember I had problems with this too. But as you can see here, hi, my name is Mantas and my age is 28. What I did here, I just printed out some text, as you can see here, hi, my name is, and then I put in a variable which holds another piece of text, in this case Mantas, and after that I added some more text and my age. So basically it's not hard to understand. It could be a little bit confusing, but you just type some text, then you just add addition sign, and then you add a variable and then another addition sign and then more text and so on. So if you guys take a closer look at what it actually does and how does it, or how it should be written, I don't think you would have any problems understanding what I wrote here. I will leave this code so you can guys see it later. I'm just gonna comment it out so it doesn't, because if I wouldn't comment it out and I would have another system out print line somewhere down below, both of these would be executed. So we can show that for just the interest. Let's say we're gonna print like system out print line. We're gonna print another variable like, well, decimal number 2. We're gonna get both of these prints out, and sometimes it could be very confusing to know what these are. So I usually once I'm done with one print, I usually comment it out and then delete, and then I leave just the one I want to show you guys. Do we have any questions, Helena?
No questions. We did have a question about if we can use float type to store 1.2, and I've answered that in chat, but if you want to say something briefly about that.
That is possible, of course. Float is another data type that requires, I can declare one just as a small bonus for you guys. Float is also a data type which stores fractional and decimal numbers. So if you declare float, let's say my float equals 2.3, the only difference is that, well, the difference between float and double, it's how huge of a numbers they can store, and it's all about how much virtual memory they consume. But this is time, I believe we can leave this for another topic because it's kind of complicated. When we declare a float, you also have to put this letter F here if you want to get it running, just to indicate to Java that this is a float. I don't think we actually need to go deeper into that because I personally don't use floats so often. I usually stay with doubles. There are a lot of programmers that actually uses floats, but I don't know. Just from personal experience, I like doubles more, and it probably is because of this small F letter.
And the F should be at the end of the, so it's after the 3. Yeah, there.
Oh yes, of course. Sorry.
So, but we rarely use this, so mostly we use the double. So this is why we maybe you will use it in different settings.
That's why I made a mistake.
Yeah.
Yes.
This is why you have Google as your best friend when you're doing programming. You always have to check.
Yeah, believe it or not. Well, currently we are programming in multiple different languages, and once I'm off from Java and I program in some other programming language, when I go back, sometimes I even have to check how do I declare a variable in Java, because like in the head, once you are programming in one language for more than a week or two, you somehow lose the grip of the one you knew before. So well, thank God you can get to that language, you can get back to that language pretty quickly, but once you start doing it, like let's say I was programming in JavaScript, and now after 2 weeks of JavaScript, I go back to the Java. Basically, all my memory is erased. So I have to start Googling these small steps, like how to declare a variable and stuff like that. It happened to me a couple of times, which is kind of shameful, but well, it's the way it is, and thank God we have Google. It makes our life easier, a lot easier.
So saying that, I just want to make a point that programming is not about memorizing something. It's about solving a problem. So that's why we have these, we have Google, we have Stack Overflow, YouTube, or if you come to one of these webinars, that's also a help so you can get started. But as long as you just solve the problem, that's the key to it. And just quickly, Mantas, we have another question. So,
Yeah,
and I did answer that, but it's good to just have it in the webinar as we are recording. Can the system.out.println execute as many times in the console as, or does it have a limit for it? And you can just explain.
you mean like if I could write as many system out print lines over here?
Yeah, and we can do that. We can, as many times as we write it, it will run.
Exactly.
Yeah.
It's going to execute every time you write it. So there is no limit. You can have as many system out print lines as you want. That's absolutely no problem. Any more questions?
No, you can go ahead.
No, I can go ahead. All right. So we have we checked a little bit what strings are, and strings are basically text. They could also we can just play with it, and we can declare another one: string some random text. Like this. Some random text. Well, it doesn't have to be letters, as you already seen. We can put different signs, like all of these. It could be a plus or it can be a number. But the funny thing is that if we type a number, we can do like this. Number as text, and let's say number is 5. We close it. Now we have a couple of numbers here, a couple of integers here. One of them are mynum, and it's equal to 8. It holds a value of 8, and the same here with the string. The string holds a value of 5 just as a text. What would happen if we would add them together? Well, it will work, but it will not work the way we expect it to work. So system out print line. Let's say we're gonna add them two together. So my num plus number as text, and let's see what happens. We're gonna get 85. And why is that? Well, since this is a number and this is a text, they cannot be added together. They can only be like what Java does out my num, which is 8, and then it prints out number as text, which is 5. So it does not work to add them together or subtract number from string or vice versa. It does not work, but we can still print them out together. Strings, like mentioned before, they can hold any type of letters, numbers, signs, and so on. And I think we have booleans. All right. In the short example here, a boolean is also a data type, which holds either true or false. The main question here probably is, why do we use them? It's not like we usually do something like we want to ask a question for ourselves, because booleans are basically asking a question, and it outputs either the question is true or false, or a statement, or whatever you call it. So let's say we declare a boolean. Do I like pizza, which is true. And let's say do I like sleep, which is false, because there's no programmers that like sleep at all. So why would we actually do something like this? Well, it's kind of, booleans are kind of more advanced than that, and it requires a lot more knowledge about what, for instance, conditionals are and stuff like that. We're probably gonna keep this for another time, but we can also print out the booleans as simple as system fine. We can also print out, for instance, the first boolean, do I like pizza, and it's gonna output true if I didn't made any spelling mistakes. No, I didn't. All right, so it's true. The same goes for do I like sleep. But where we can use them more, I'm gonna go to that very soon. First, we're gonna cover some operator signs, and after that, I'm gonna show you how can we work with different booleans and why are they being used. But first, on what are the operator signs? Well, Java and most of the programming languages, they have different operator signs, and these are arithmetic operators, which are basically the same as we have in mathematics. Assignment operators, we already seen one because equal sign is an operator sign or assignment operator. Then we have comparison operators, which are also the same as in mathematics. We have some logical operators and bitwise operators, which we're not going to talk much about today. Arithmetic operators, well, I believe they speak for themselves. We have addition, which is plus, and minus for subtraction, and asterisk for multiplication, and slash for division. Well, basically the same thing you do in mathematics, that you can achieve the same kind of results with these arithmetic operators here in programming too. We have more. We have an assignment operator. We have already discussed that. It assigns a data or a value to a variable. Then there are some more operator signs, which are comparison operators. In this case, as you can see here, we have two equal signs, and these actually check if one variable is exactly the same as the other one. So we could have like two different, let's start like this. We can go 2 steps down, and let's say we have integer age equals 30. And we can go like integer another age equals 25. We can check if this age is exactly the same as this one with equal to operator sign. The same goes for not equal, just the opposite. We can check if one variable is not equal to another one. We can do some tests here and see what happens. Let's say that we're going to check if age is equal to another age. And we're going to see what we're going to get. Oh, we get an error because I forgot the semicolon. Like this, and it says false. And tada, this is where variable or Boolean variables come in. We haven't created any variable, Boolean type of variable, but we're still getting the Boolean value outputted in case these two variables are not the same. So this is where Booleans come very handy to check if something is the same or something is not the same in our code. We can just type two equal signs and see, are they the same? No. We can do the same with the opposite, not equal. If you can remember, not equal are written like this, exclamation mark and then the equal sign. And this is going to output true because age, which is 30, and another age, which is 25, are not equal to one another. However, if you would have another age like 30, it will display false. So I was wondering in the beginning, why do we need something like equal to and not equal to if we can get the same results by just typing one of them? Well, as I told before, not equal to very much used to be sure that if let's say we have a block of code here, and if these two variables are not the same, we're going to do something with this here. And if we have Well, it's very hard to explain since we are not covering conditionals today. If and else if conditionals, but this is where the variables like Boolean variables are mostly used, because we can check if one variable is another to another or equal to another variable or not, and based on the answer we get, which is either true or false, we can do something down below. We can execute line of code if they're not equal or if they are equal. But in this case, we can just see that age, we can check if age is not equal to another age, and which is false because now they are both the same. We could also do the same thing and get the Boolean value outputted if we check greater than and less than, because greater than and less than, they're pretty much the same as they are in mathematics. We can try that. We can check if age is greater than or greater than another age. And we're going to also get false because age is not greater than another age. However, there is another comparison operator which can be used to check if greater than or equal to. It's basically typed with greater than and just another, and we just add a equal to sign like here, like this. Now we're checking if age is greater or equal to another age. What we're gonna get? We're gonna get true. It goes the same way around too. If we check the other way around, let's say we're gonna change that to 25 or 20. We're gonna get false because age is clearly not less than 20. So this is how these operator or comparison sign operators work. You can get you can check one variable if they're equal to or not equal to or greater or less than to another variable, and you can get outputted like false or true or whatever the answer is. Then we have oh, of course, we can have some short practice here. My question, I would like you to type a short answer into the chat or chat box. If I ask you what is the data type of the first line here, could we get an answer? What is the data type of true? What could it be? Helena, once we have the answer, maybe you can just shoot it out to me.
Yeah, so they have it correctly. They're saying Booleans, all of them. So that's correct.
Boolean, exactly, nice. And what is the data type for hello?
Yep, so it's the same string. And just
String.
remember string with a capital S always.
Yes. And why is that? Because the string is non-primitive data type. And these data types, as we mentioned before, are created by the programmer himself. Booleans and all the primitive data types are already defined, and that's why they are written with lowercase letters. All right, what do we have here? What kind of data type is this? 5.
So we have the first answer, that's int or integer, the whole name, but integer and int is the correct one.
Great. What about the next one?
We're still waiting for some answers. So 5.6, if anyone knows what the data type is, you can just print it in the chat.
What is the 5.6? What kind of data type is that?
Wow, we got a whole list. Great going, everyone. So
great list. What was that then?
Double, and someone also said float or double, and that is also correct.
It could be float if we would add a little f here at the end. It could be float then. Right now, it's a double, but either way, it's true because it's a decimal number. And what do we have here? this number 5, what kind of data type is that?
So yeah, string is the correct answer, and they are also typing
String.
this.
And why
Great
is it a
going,
string?
everyone.
Well, it is a string because it's put into double quotation marks. Everything that's put in a double quotation marks are strings. And this one, what data type is that? Data type where we add two values together.
We also have the correct answer for this, and it's int.
Int. And this last one is
double. So we got the right answer to that. Great, everyone.
double. Well done, everybody. This was, well, I don't know, maybe some of you feel that this was a little bit too short or too easy, but from my own experience, and we were talking this through with Helena, when we started studying, we really wanted something like this in our course, in our school, because we never get a chance to know all the what is a variable, what is a variable, what's a variable, honestly, what does it how does it look, and why does it look like this, and why are these different data types and stuff like that. We never got to know that. We have to learn it on our own, and sometimes it's very hard to do that, because I personally don't like writing code. I don't like doing stuff when I don't know what it does. I'm very skeptical around that, especially if we are covering some, well, advanced programming in school, and I don't understand half of the things it does. I know how to do it right, I know how to run it, but I don't understand what it does and how it does it. That actually kills me inside, and I only get frustrated. So this small webinar of ours was to introduce you guys to data types and mainly variables. Well, all this code I wrote here, I'm gonna like make it a little bit nicer today as soon as we are done, and I'm gonna upload it on something called GitHub. GitHub is a place where programmers can upload their code, so it can be visible to other programmers, or if we have any collaborators, we're working on the same code together, we can put our code there and we can work on this remotely. So you're gonna get the access to that. I hope that you learned something new today. And of course, if you have any questions, if you want to ask something, even if it's more advanced stuff, feel free to add me on LinkedIn. I will be more than happy to answer your questions, and I will do my best to help you. I hope you found this interesting, and who knows, maybe in the future we will have more. We may have, maybe have to talk about something more advanced in our next webinar, if we're going to have any. That's all depending on you guys. So I hope you enjoy. I hope you have a great time. And I hope to see you next time. So Helena, thank you.
And I just want to say we can't give up an applause, like, because we can't hear you. But I said before, give Mantas some stars. Just type in some stars in the chat to show him this amazing presentation. I mean, this was great, and like you said, just covering the basics like this, it's just, yeah, you're getting a lot of stars, Mantas, in the chat now.
Oh, thank you.
So,
Thank
and
you
as
so much.
as Mantas said, I posted how you can get in touch with Mantas and how to follow people in data. So for all upcoming webinars we are planning, we will post all the information there. All planned webinars are always posted there, both in the Facebook page, you can see them in the event side, and you can also just check the post there. So you get super many stars. Well done, Mantas. This was just super.
Thank you so much.
Good.
I may mention that this was my first webinar ever. I have never had any experience to something like this, and I'm very honored that you were my first listeners. I hope it gave you something. And as I mentioned before, if you want to start, I would like to encourage each and every one of you to start programming. If you if like if you have this feeling, oh, I would like to become a programmer, but I'm really sure how to do it, or maybe it's too hard for me, don't hesitate, just do it. I had the same thoughts, and well, like I said, I'm more than happy that I did it. And if you have any questions, you want to get started, you want to know more, feel free to add me on LinkedIn, reach out to me, and I believe we can get this fixed.
Thank you so much. I mean, just saying that this was your first webinar, it's amazing. So big up for you, Mantas. And thank you for everyone who joined in. And I just really liked how you were really active, asking questions and being active in the chat. It was very nice to see all of you from all around the world. I love this when we can just connect with each other like this, just one Zoom call from one continent to another. That's just amazing. So I hope to see you soon again. All stay safe, and I wish you a wonderful Saturday. Yeah, Mantas? Yeah, you have some links.
Yeah, I would like to also name a couple of links. For those that really are interested in programming, Solo Learn application, which you can get on Google Play Store and Apple Store. It's free of charge. Of course, you can pay if you want to have full features, but I never paid, and I was very happy to have this program. There are a lot of different programming languages, so you can just check that out. It explains pretty well what each and every part in programming or in Java or any other language is. And we have some Udacity Java programming basics, which you can also check out. And then object-oriented programming Java. We also have this online Java compiler. It's the same. I was writing stuff here. So when you want to try something, don't hesitate, because the best practice, the best way to learn something is by actually doing it. So thank you all. I hope you enjoy.
Thank you so much. And we will share the slides from this webinar in the People in Degida's LinkedIn page. So make sure to stay tuned from there. Thank you so much, everyone, and have a wonderful Saturday.